We have an example 10.1 for LU decomposition with Gauss elimination. We will just actually decompose the A matrix here. You can see our example. We separated the A matrix. Then this A matrix, we will going to decompose it to a lower and upper triangle using the LU decomposition we mentioned in the previous slides. So first of all, what we need to do is we need to eliminate these, because this is the Gauss elimination, but just for A. We are not going to eliminate from the B's. So to eliminate this, we will have this divided by the first one and multiply the first row by that. So basically, first, what we need to do is initially A21 will be eliminated from row 2. So for that, we need to have F21 equivalent to 0.1 divided by 3, which is 0.3333. We can have many threes. We can just keep in after this number. So we will multiply the first equation by this one and subtract from the second one. Then we will have the second equation. Also, in the second step, because you know this already, I'm not going to do all the details. In the second step, we will eliminate A31 as well. Will be eliminated from row 3, and for that we will have F31 is equivalent to this time 0.3 divided by 3, and we will multiply this by the first row, then subtract it from the third row, and these will be eliminated. Of course, these will be updated. Then we can write the updated function like this. If we do these operations, multiply by first row and subtract from second and third rows, then the A matrix will be, we can write maybe here, the first will be the same, but the second will be 0 here. Then when we multiply this by this one and subtract from this, basically we will have 7.00333, and also subtract from 0.3 here, then we will have minus 0.29333 and 3. So it didn't fit, but you will understand this. And subtract from the third one by multiplying by this one, and subtract from the third one. Then this was 0 again, it will be 0 again. And the other term, for the other term, the multiplication is 0.1 basically. You can see here 0.1. When we multiply by this, it's 0.01, and subtract from here, then it becomes 0.19. So simply here the second term is minus 0.19, and the third one, so we multiply 0.1 by this 0.02 and subtract from 10, which makes 10 minus 0.02 plus, that means 10, then it becomes 10.02. So we obtain this A prime, let's say. Now in this we will eliminate this one. Then as the third step, A32 prime, this is A32 prime, so will be eliminated from row 3, and we will multiply the second row by this. So F32, maybe we can say this way, and we will actually 0.19 divided by, now we will multiply by this. That's why we are going to divide by this to make it 1. So this is the value which gives us minus 0.0271300. And subtract this from the third row. So let's write here, multiply F32 by second row and subtract from third row. Eventually, we will have the U matrix by this. When we do these 3 steps, we will have the U matrix. And by the way, the third row means this. For the A prime, we will do the third operation. And in here, the first term is the same, 3 minus 0.1 and minus 0.2. The second is the same again, 0, 7.00333 and minus 0.293333. But the last term becomes, this term will be 0, and the last one, when we multiply, becomes 10.0120. So this is our U matrix. And for the L matrix, we will use these F21, F32, 31, and F32 as the lower triangle. So that's simple. L is equivalent to, then we will have a diagonal like this, 1, 1, 1. And the lower diagonal, actually upper diagonal are 0. And the lower diagonals are F21 here. So 0.333333. And F31 is at the 3,1 here, 0.1. And F32 becomes here, minus 0.02713. So as you can see, we obtained U and L. In short, the Gauss elimination with these 3 steps, we obtained the upper triangle, which gives us U, and for L, we will have these F21, F31, F32 as the lower triangle, and that's it. So we can write here, L is obtained by F21, F31, and F32. So if you multiply these, you will get A matrix. So A matrix becomes, but you will multiply by actually L by U. So the order is important, not U by L, but L by U. If you multiply this, there can be some round of errors. So let me multiply it here to fit in. 3 minus 0.1 and minus 2, 0.09999, 7 minus 0.3, 0.3 minus 0.2, and 9.99996. So there are slight round of errors here, these ones. It's because we actually use some rounding to represent these numbers, and when we multiply back these, it gave us some round of errors. So when you compare this with this one, it's almost the same except the round of errors. But that's okay, these are very small round of errors. They can exist, no problem. So this is the LU decomposition stage. Now after this, we will use to solve for x's. That's why we need to, apply the Gauss elimination for these. In the next step, for that we will use L and U separately, for the substitution steps. Let's move on that in the next slide, then show that in this example as well.